So I'm here today to give you a quick intro to using a program called Audacity, which is for recording sounds and then analyzing them. So without further ado, let's record a sound. This program is pretty easy to use, although it has a lot of features that we don't really need to use. So I'm going to find the record button right here, this red button. I'm going to press it and I'm going to whistle a little tune. And then I'm going to stop, and here we see the sound recorded and plotted on this graph. This graph shows time along the x-axis and sound intensity or loudness on the y-axis. And we'll see it goes from positive to negative because, as you remember, sound waves go positive to negative. So let's look at this thing. We can actually use this representation here to zoom in and see the actual individual sound waves. So let's go up here and we'll see the zoom symbol, and I'm going to zoom in. And if I want, I can pick some particular place to zoom in. And we see as we zoom in the shape of the sound wave, and you'll see these strange envelope functions that possibly you might understand from class. Let's keep zooming in. And we finally arrive at the individual sound waves that were moving through the air that were picked up by the microphone on the computer. And there they are. You can make various measurements of them. You can measure their duration, for example. You can measure the time from one peak to the next peak, or you could measure several peaks and then divide that by the number of peaks, and that would be measuring the time between one peak and another. So that would give you the what would it give you? It would give you 1 over the frequency, the oscillation period. Okay, so that's how you would measure the shape of the sound waves. It might be interesting to see if different sounds produce sound waves that have different shapes. Okay, let's zoom back out again. And we're going to do the other thing that this program is good for, which is called spectrum analyzer. So I'm going to again pick just part of the sound that I made, one of those notes that I whistled, and I'm going to go up to analyze here, and I'm going to pick plot spectrum. And a window will appear, and in that window we see the sound spectrum. So a spectrum is typically a graph of frequency on the x-axis and the amount of energy at that frequency on the y-axis. The units are decibels, so you don't have to worry too much of what they are. There's something to do with the loudness of the sound or the relative loudness. Now, you see that there are all these bumps and peaks and wiggles, and these represent the different amounts of sound energy that are present at different frequencies in the whistling that I made. So for example, we might expect the biggest peak in this spectrum might occur at the note corresponding at the frequency of the note that I whistled. Now, there are various choices on here that make a few differences. One I would suggest is notice that the axis for frequency is in log space. It's log of frequency. So it might be a little easier to understand if you turn it into linear frequency. The other choice you could make is this function, which is called the window function. And it basically either suppresses or strengthens the other frequencies that exist in the spectrum. So I'm just going to pick rectangular window, which is basically the simplest choice that we could make. And this one is probably what I would pick. So here we see the underlying fundamental frequency and various other frequencies that are present, but we really only see the strongest ones. Now, if we look at some of the features, as I move my cursor around, you see there's this vertical line that follows it. And wherever it is, we see the value of where the cursor is, but we also see the nearest peak. So this can be really handy. So this shows that peak that my cursor is closest to right here is at 1800 hertz, and it also tells you what the nearest musical note happens to be. So now you've got all the tools you need. You can look for what different frequencies are present in the spectrum, you can look at the shapes of the sound waves, and you can make recordings of different sounds and analyze how they're different. So have fun!